Hello everyone, it's a great day for math. So now I'm just going to go through a few questions on circle properties and apply the angle properties that we need to know. So first and foremost, let's take a look at the information in the question. O is the center of the circle, A, B, C, D are points on the circumference. Okay, very crucial, okay? A, B, C, D. Next, ABO is 32 and BCD is 117. Great, they are all marked out already. So let's find A. Angle BAD. Now, based on what we want you to try, take your pencil or your fingers and trace out. Where is the arc or chord that makes up BAD? So BAD is over here. If I use my fingers to trace, I'll use the highlighter in this case. You'll notice that it goes to the arc BD. Okay, so the question is, where else does this go to? If you take a good look, it doesn't go to anywhere else except over here to the point C. Okay, highlighter, where are you? Here. Now notice in green now, using my fingers and tracing out, what shape have we formed? A four-sided figure where all the points are on the circumference. So therefore, angle BAD must be 180 degrees minus 117, which is 63 degrees. Very important. What property did we just use? Very good. Angles in the opposite segment. So numerical answer is important, but the explanation is equally important to answer the question completely. Okay, A done. Angle ADB. So I'll now just erase the rest first. Oops. Erase, where are you? So as not to confuse us for the rest of the question. And now we'll also just put in, okay, we know this is 63. Okay, ADB, ADB. So again, use your fingers and trace out what chord and arc does it makes up ADB that we want to find. So it's this fellow over here. How do we find it? Right, and the arc that makes it up is over here. Where else does this chord go to? Fantastic. The center of the circle. Okay, so basically, if I knew this angle, I'll definitely know ADB, sorry. So let's do some work. Notice that in triangle AOB, it is a isosceles triangle. So therefore, let's first find angle AOB using properties of an isosceles. 180 minus the two base angles of 32 to get 116. So this is an isosceles triangle. Right, so what property are we using here? Very good. Angle at the center is 2 times the angle at the circumference. So we can therefore conclude that angle ADB is 116 divided by 2. Right, it's the smaller angle which will give us 58 degrees. So reason angle at center equals 2 angle at the circumference. Done. Then I will proceed to erase again. And put in the values that we know, okay? So this would remain as pencil marks on your own working, right? 116. This is 32. This is 58. Right. Last one. Angle OBD. Again, trace out again to see if we can use any circle property. OBD. A weird looking one. So technically, you realize that it doesn't go to any arc or any chord specifically. So we're going to have to use our wits a bit to try and figure out how to find OBD. Now, if there's one trick that Mr. Tan will teach you, is that drawing a line purposefully would help us find the answer. And usually we draw a line to create shapes that are very useful to us. In this case, I will draw it from O to D. By doing that, I would have created another isosceles triangle ODB. Okay, and by doing that, actually I can find this angle BOD first, because BOD will be linked with, let me use another color, maybe use a blue. BOD goes to arc BD, and it also goes to here. Why do I want to do this? Because angle at the center is twice the angle at the circumference. So I can first find angle BOD by taking 63 times 2, which is 126 degrees. Angle at center equals to angle at circumference. First, so BOD found. Now that I've created the isosceles, I can find our magical OBD, because angle OBD is the base angle of the isosceles, and I will just take 180 minus 126 and I'll divide it by 2, and that should give us 27, and we have used the property of an isosceles triangle. Here we go. Right, let's continue on with the fantastic math. Read the info. AB meets the diameter CD. So diameter CD, very important, very useful. I will just highlight this. Diameter. Okay, that's a very useful chord. Meets it at E. Okay, remember E is in the middle of nowhere, huh? Nothing special about E in terms of a circle property. And ABD is 60. Fine. Let's first find A, CBD. Now clearly, CBD, if I were to use my highlighter and my fingers again, it goes to the chord CD. Now, does this ring any bell? Yes, angle CBD is simply 90 degrees because it's created by the chord CD, which is the diameter of the circle. So angles in a semicircle. That's the second angle property. A is easy. Next one, CDA. I will erase the rest. CDA. And I'll just write in red that this is 90. Yep. Okay, next, CDA. CDA. Again, I will use my highlighter, CDA. So this is the angle. Where else does this chord or this arc go to in the circle? Where else does it go to? Yes, it goes to B. So in doing that, we can actually see another circle property here. Relationship between this angle and this angle. So CDA is the one we want to find. If we know CBA, we can say that CDA is the same. So let's first find angle CBA, which will be 90 just now, found out, minus 60, 30 degrees. We call this complementary angles, meaning 90 minus 60, okay? They add up to 90, the two angles. Next, angle CDA will be the same exact angle, 30, because of angles in the same segment, which is our third circle property. Okay, so 30, 30. Last but not least, DOA. DOA, which is the center of the circle. If CD is the diameter, I can assume O is somewhere here. And because it's in the middle of nowhere, DOA, and nothing is drawn out for us, right? We will draw our own line. And in doing so, what triangle did we create? A isosceles triangle again. DOA, which is this angle, basically is the, you can call it the top angle, but we already have the base angles of the isosceles, so therefore DOA is simply 180 minus 30, the two base angles, which would give us 120 degrees. We again can say properties of an isosceles triangle. And we are done. Woohoo! Alright, more fantastic math. Let's read the info. AOC is the diameter of the circle. Fantastic, very useful result. I'll just highlight it. Next, 38 ASO drawn out. BAC also drawn out. So we can start. Let's start with A. CST. Right, so following the usual advice, which is to take your finger and trace, CST by right is made up of this, but there is no circle property directly related to a pointy outside of the circle, except for the tangents. But the very important thing about tangents, this whole fella will be 90 degrees, because ST is the tangent and OS is the radius. So that will be 90, a useful result later on. Not only that, do we also see that actually ASC is a right angle as well? What property is that? Very good, angles in semicircle. So I will first mark that out. Angle ASC is 90 because of angles in the semicircle. Fantastically useful property from the diameter of the circle. So once I know that is 90, I can go on to say that angle OSC is 90 minus 38. Right? Because they both add up to 90, so that gives us 52. This is called complementary angles, similar to the previous question. So now if this is 52, to be complete, I will also conclude and say that angle OST is 90 because of tangent perpendicular to radius, and therefore say that angle CST is finally 90 minus 52, which is 38. Complementary angles. So that's A. Pretty long, but don't worry, the rest should be faster. ABS. Okay, let us erase. Let me erase, I mean, the not so important arcs that you should have used your finger to trace. And I will also put in the other values. This is 38. Okay, next, ABS. So again, use your finger. ABS, they go to the arc AS. So where else does this arc go to? A few places actually. It goes to point C, and it also goes to the center of the circle. So we have a choice. And I'm by experience saying that the center of the circle is more useful than the other angle ASC, because in this triangle I can find angle AOS more easily, because that's a isosceles triangle, right? So 180 minus 38 minus 38, which is 104, isosceles triangle. And therefore, angle ABS is half of that, 104 divided by 2, which is 52 degrees. Angle at center equals 2 angle at circumference. I'll move on with C here. BSO. BSO. Let me erase our marks again. Okay. Put in the info that we have. 52. Okay, next. BSO. So again, if you were to use your fingers, it doesn't really go to a chord or an arc. However, the angle that we want to find, BSO here, is part of the 52 degrees of angle OSC, right? So if I were to find this green angle instead, I can take 52 minus the green angle. So now notice that if I were to trace the green angle BSC, it will go to the arc BC. Okay, let's not confuse you. We're looking at another arc BC here. Where else does it go to? Yes, it goes to BAC as well. So this fella here has to be 26 as well, meaning angle BSC is 26 because of angles in the same segment. Therefore, angle BSO is 52 minus 26, which is 26 degrees. No particular reason for that, so we can just leave it as that. Let's erase. Okay, we're almost done. Last one. BCS. BCS. Wow. In the middle of nowhere, so I have no choice but to draw this. BCS is this whole red angle here. Once again, use your finger to trace. BCS actually goes to this huge chord of BAS, right? Where else does it go to? Don't know if you can spot it. It also goes to point A. So what figure and which property is this? Yes, angles in the opposite segment add up to 180. So isosceles triangle means it's 38, right? So I can say that angle BAS is 26 plus 38, which is 64, and therefore angle BCS is 180. It's complementary. 180 minus 64, which is 116. Angles in opposite segment, the four-sided figure with all the points on the circumference. And we're done. Right, now for this final practice question on circle properties, let's quickly go through it. And bear in mind the way to find the angles using shading, tracing with your fingers, and drawing out the arc. It really helps you determine which angle property to use. Right, so AC is the diameter of the circle. Very useful. I'd like to highlight it. Next, angle ABE is 26, so already drawn fine. So let's do A part 1. It's a bit small. ACE. ACE over here. Using my fingers to trace, ACE is here, and you notice it also goes here. They all come from the same arc in the same segment, AE. So, therefore, angle ACE is very simply 26 degrees. Reason, angles in the same segment. First one done. Let's erase. Clearly, this is 26 as well. Next, CBE. CBE, again, trace using your fingers. CB goes here. Now there's a choice here. Technically it goes to the center of the circle, which I can draw here. And it also goes all the way till angle A. CAE, I mean. So which one is the more useful one? At this point of time, you realize information is limited, right? So take a look at the previous part and see what is useful. Yes, can you see that the triangle COAE is an isosceles? So therefore, angle COE can easily be found using base angles of an isosceles. And that would be 128 isosceles triangle. Now once we know this, we can do angle at the center is twice the angle at the circumference to find angle CBE. Right, these two blue angles. So angle at the center 128 divided by 2, which will be 64. Angle at center equals 2 angle at circumference. See how useful tracing things out are? Right, so I'll write 128 and I'll write 64 here, and I'll erase the rest of the highlights. Next, CD part 3. Once again, trace it out. CDE is here. Where else does it go to? Very good, it goes here. And what do we have? What shape do we see? Fantastic, the four-sided figure. So angle CDE is simply 180 minus 64, which is 116. Reason, angles in the opposite segment. They are complementary. So this will be 116, and I will erase the rest of the highlights. Okay. Next, angle AEQ. Right, so based on the question, EQ is the tangent, so Q is not really drawn out there. Apologies about that. So AEQ is talking about this angle in blue over here. Okay, maybe I should use red. Okay, AEQ over here. So let's establish some facts because of the tangent. So therefore angle, OEQ is 90 because tangent is perpendicular to the radius. First thing, this whole thing is 90. Big fat one. So let's first find this angle here, since I know that OEQ is 90 already. So that's the base angle of this isosceles triangle. Can you see that? So I'll first proceed to find angle EOA, which is 180 minus 128, angles on a straight line, which is 52. So angles on a straight line. Sometimes I write it as a supplementary angles. Okay, first one. So this is 52. Next, because of the isosceles triangle, so therefore angle OEA is 180 minus 52, and I divide it by 2, which is 64. So isosceles triangle. Last but not least, so therefore angle AEQ is 90 minus 64, which is 26 degrees. This is complementary angles. Add up to 90 degrees. Right, last but not least, given that AEB is 38, let's erase some of this very messy parts and put in the values. We have 26. We have 52, no, not 52, 64. This is 64 as well. Okay. Now, new info. Let's put it in yellow. AB is 38. AEB. Let's really small one. The one in yellow is 38. Okay, this one. 38 degrees. Determine whether lines EO and AB are parallel. When you say determine, it means I have to prove and I have to show. Check with values to justify. So where is EO and AB? EO is this line here in green, and AB. Now, to check, basically we need to use facts that come from parallel lines. So when I have parallel lines, everyone, what are some of the most common things that occur? Very good. Alternate angles. Is there alternate angles that I can check and prove? Yes, they are. Which one will be the most useful? I will now use red. This one. This one, because I can easily find the two values here. And if they are the same, this angle here that creates the Z and this one over here, if they are the same, then the two lines are parallel. So let's double check. So angle OEB, the really tiny one in red over there, is found out to be 64 degrees minus 38, which is 26 degrees. Yes, so since angle OEB is the same as angle EBA, which is 26, therefore by alternate angles, lines EO and AB are parallel. So in the O levels, you might be required to justify such things. So repeat, to prove that they are parallel, I needed to find the two internal or alternate angles and prove that they are of the same value. Since they are the same, then it must be that EO and AB are parallel. And we are done.